Hi all, welcome to Any Too Many Networks. So today I came with another question that would be asked in the interview. This question is basically asked to me when I was applying, when I was attending an interview with Arista Networks for my internship. So this question was asked to me by an interviewer. So the question would be like, for example, if you have a for example, if you see here, you have a PC here on this side, and you have another PC on this side. So let's consider this is customer A and this is customer B. And if customer A is trying to reach out to customer B, would there be any change in the source? Would there be any change in the source IP and the destination IP? For example, if I'm trying to ping, because here we always try to use a ping utility command to check whether that destination is available or not, because that's the only thing, that's the only way we can actually use here to see whether on the other side the customer is available or not. So for example, if you see here, if 10.0.0.10 is trying to reach out to 10.50.0.0.10, so if the ping is successful and if you are getting ping reply from this device, then that means it's working. And people might say that the source IP would be changing when it comes to this hop, and then when it comes to this hop, the IP would change, and then when it comes to this hop, again the IP would change. So people might, who doesn't know how does a routing works, they might say like this, but ideally the answer would be the source IP and destination IP will never change at all, whether you are changing how many hops, whether you have like lot of hops, it doesn't matter. The source IP and destination IP will not change. So what I'm gonna do is I'm gonna walk through the real simulation that how a packet flow from customer A to customer B, which is here in this case 10.0.0.10 to 10.50.0.0.0.10. I'm going to show you like how does a ping ICMP packet flow from this end to this end without a source IP and destination IP, without changing a source IP and destination IP. So let's walk through. So I'm going to use this simulation on this side. So what I'm going to do is I'll go to this PC and I'm going to show you again the command like R table again here. So if you, so you right now there is an entry here for 10.0.0.1. So that is the default gateways IP here. So I'm gonna delete that entry so you can actually see that again if you give r-a, there's no entry at all. So what happens is every link there's going to be a change in the source MAC and destination MAC, because every time you try to ping in this link, in this particular link, there's going to be a change in the source MAC and destination MAC, because it whenever you try to ping, the ping packet will be on hold, and then an ARP protocol, ARP packet would be, ARP request would be sent to this router in order to find the MAC address of this particular interface. So that's what I'm going to show you. So what I'm going to do is now here, I'm going to start the simulation before I do that. So let's click on the simulation. So I'm going to play this. I'm going to reset everything. I'm going to play this. So what is this packet? CDP. Okay, let's go here, and then what I'll do is, so I'm trying to ping from 10.0.0.10 to 50.0.0.10. So I'll go here and then I'll give a ping command. So you see this, if you go here and then place your cursor here, if you see here and place your cursor, it says ICMP. You see there are two packets here, two messages. So ICMP is on hold, and then there is another packet that is displaying here, which is ARP. If you open this packet and see, you see this one. It's giving the 10.0.0.10 and the destination is 10.0.0.1. Because we have configured this 10.0.0.1 as a default gateway, so it knows where to send this packet. And if you actually open the ICMP packet and see, the source IP and destination IP is the same, which is 50.0.0.10. That is the destination IP that we are trying to reach out. So it never changed. So it kept this packet on hold, and what it tried to do was it tried to use an ARP packet, ARP request packet, to send it to a router in order to know the MAC address, because we have deleted the ARP entries that were installed on the PC. So it is trying to fetch the MAC address of this router's interface. So let's see what is the next step it's going to be doing. So it sent to the switch, and switch is going to directly send it to the router, because you might say that switch will be like flooding whenever it receives an unknown frame, but here I have already set up this topology, so that's why it is sending it to the direct, because I have not deleted any ARP entries in the switch table. So it directly send out to the router. So if you see here, so you can see the inbound and outbound details. So people might be getting confused, what are this inbound and outbound. So inbound details are nothing but when a packet is entering into the router. If you see here, the source IP would be the 10.0.0.10, which is PC's IP address, and the destination IP address will be 10.0.0.1. Here see, source IP is this, and then destination IP is this, which is target IP, which is 10.0.0.1. And if you see outbound details, it must have prepared already. Here you can see the source IP changed because the routers. So when it is coming back, it's going to be outbound details. And the destination IP is 10.0.0.10, and then here is the target MAC address. So this is the MAC address that is related to 10.0.0.10, and then source MAC address would be the router's interface MAC address, physical address. So that's how it gives details, and that's how the packet flow works. So next, if you see and if you click on the next, it's going to be sending that ICMP packet, sorry, the ARP packet back to the PC. We'll see that here. You see these guys? So it's not going out of this. So ARP packet is like always, goes inside the LAN. So this is inside the LAN. It's going only inside the LAN. So it's coming back to the PC. So you see it came to the switch, and then switch is gonna unicast to the PC. See, now there you go. So once the PC got that packet, you see the tick mark over there, it shows that packet actually got received. And then now there you go. So the pink packet that you see, ICMP, it has moved forward, and then now this packet is gonna go next to the next hop. This is the ICMP packet. If you see, now it finds it actually found the destination MAC address of this, and then now it's going to construct the outbound. So if you go and see outbound details here, see the source IP and then the destination IP. So it knows the source MAC address and the destination MAC address, so obviously the packet is going to be sending here to this. And then when it receives at the router, so what does router do? We all know router does routing. How does router does routing? Because I have configured an OSPF protocol, which is a dynamic routing protocol, is helping here to calculate the best routes possible here. So at this router, all these routers I have configured OSPF in order for calculating the best routes. And so what happens is, whenever an ICMP packet is received here at this router, so it's gonna look at the destination IP here, which is 50.0.0.10. So I'm gonna show you here. So I'm gonna click on the next. So the ICMP packet is actually came to the switch, and then it's gonna be sending to the router. So again, you might say that this router is gonna send it to. So you might say this ICMP packet is directly moving forward to this PC, but again there's a link here. Again there's a link. So what happens is, again this router keep this packet on a hold, and again it does a ARP request, because it doesn't know the MAC address of this interface. So what happens is, it keeps that packet on hold, and then it sends an ARP request in order to know the MAC address of this interface. So if you click on next, oh, it's giving it's actually, the packet is actually going to this router, because I think since I have set up this topology earlier, so I haven't cleared the ARP entries on this particular router. So that's why it's going on. Otherwise, usually what happens is at this point, on this link, what happens is this router is gonna ask, then ARP request will be sent from this router to this router in order to find the MAC address of this particular interface. Since it's already learned, so the packet is already sent to this place. So if you open here, so if you see, the source IP is 10.0.0.10 and then destination IP is 50.0.0.10. So how many routers you have in between, it doesn't care. The source IP and destination IP is not even changing at all. So guys, this is what I was telling you, that you have to be very careful when you are telling this to an interviewer. The source IP and destination IP, if you look at inbound and outbound details, the destination IP and the source IP is constant. So this is what you have to be taking care of it. So let me click on next again. You see these guys, the ICMP packet has been sent to the next router. You might say how this is actually going, exactly going to that point, because I have already configured OSPF protocol here, and it is taking decisions by using OSPF protocol. Okay, so it's sending directly to the switch, sorry, PC. And now the reply you would be seeing right now, it's going to go back. You might see that, see. So this is the ICMP reply. You can see on this side. So it's going to the switch, going to the router. You might say again, if it is coming, the ICMP reply is coming back from 50.0.0.10 and it is going to 10.0.0.10. You might say that, oh, it is at this particular router, so the source IP would be this 30.0.0.2 and then destination IP would be this. No, it doesn't work like that. Again, whenever this PC construct the packet, the source IP is 50.0.0.10 and then destination IP is 10.0.0.10. Only these routers will help, and the routing protocols will help to direct the packet in particular direction to the destination, final destination. So again, if you go and see this packet, see 50.0.0.10 and then destination is 10.0.0.10. There's no change in at all. So this is constant. Okay, the routing protocols are helping here to forward this packet. So if I'm again clicking on the next, again next, and you see this, the packet has been reached here and you have successfully pinged from this device to this device and you got a ping reply. You sent a ping request and you got a ping reply from that device. And if you click on this here, 50.0.0.10 and 10.0 never changed at all. So this is the answer that you're going to be giving. So I just wanted to show you how does a packet walk or a packet flow from one end to another end by showing or by opening the packets. So this is how it works. So one thing you have to remember is whenever you try to ping from one device to another device, until unless you have a NAT. For example, if you configure on this particular router as a NAT and you are using private IP addresses, so what happens is NAT will have a function of PAT, so it uses port address translation and it changes the IP address from at this point to this point. The inbound and outbound details would look different, but here in this case this is a normal simulation, and whenever you don't have a NAT in between, then this is how it works. So this is going to be the answer, guys. So thank you so much. Please do like these videos and share it to your friends, whoever is applying for this network engineer roles. Thank you so much. Have a good day.